So now we will be starting with the Planck's quantum theory. So the theory given by Maxwell that the energy radiated was a continuous flow of energy. This theory could explain the phenomena of light very well, but some more phenomena could not be explained by this theory. So a new theory was put forward by Planck to understand these phenomena. So first of all, look at what these phenomena were. The first of these phenomena was the photoelectric effect. Photoelectric effect. So what is photoelectric effect? When we take a metal surface and light is incident on this metal surface, let the wavelength of this light be lambda. So this light, when this is incident on this surface, some electrons are ejected from this surface, and these electrons possess some kinetic energy. So this is known as the photoelectric effect, and this could not be explained by the Maxwell theories. The second phenomena was the spectral lines that were emitted by the excited atomic gases. So as I have told you, we will study about spectrums in the later lectures. So the spectral lines that were given out by atomic gases, these were known as the line spectrum, and they helped in the identification of elements. So this cannot be explained by Maxwell theories. Now, before understanding the Planck's quantum theory, let us understand what a black body is. So I am introducing a new term, that is black body. So black body is any ideal body. I am saying the word ideal because black body in real life does not exist. So black body is any ideal body which absorbs all the radiations that are falling on it. So if E amount of radiations are falling on the black body, then it will absorb E amount of radiations. So that is, it will absorb 100% radiations that are falling on it. There is no such body that can absorb all the radiations that are falling on it. So black body is an ideal body. So it does not exist in real life. So you will study in physics in your later classes that the body which is a good absorber is also a good emitter. So black body is a very good absorber and a very good emitter. The radiations that are emitted by the black body, these radiations are known as the black body radiations. See, you can easily remember this, that the energy coming out of the black body, this is known as radiation, and as the body is a black body, this will be known as the black body radiations. Now Planck, he gave some formulas to understand this energy and the terms related to it. So according to Planck, energy was directly proportional to the frequency of light or the frequency of wave. Light is also a wave. So according to Planck, energy was directly proportional to the frequency of the wave. To remove this proportionality sign, he introduced a constant, that is h. H is known as the Planck's constant. And the value of h is 6.626. It is 6.626 into 10 to the power minus 34 joule seconds. So energy was given by h times nu. Now you have studied that the speed or the velocity of the wave is lambda times frequency. So frequency comes out to be speed upon lambda. So energy is hc by lambda. Now what is the value of c? C is the speed of electromagnetic wave or light. So the speed of light is 3 into 10 to the power 8 meter per second. This is the speed of light. So c is a constant, h is a constant, and lambda will vary for different lights. Now this is a very common formula. What you need to know in this formula is it includes a n. So this formula is originally n times hc by lambda, where n is the number of particles and hc by lambda I have told you already. So this lambda is varying. So if we modify hc into 1 upon lambda, and 1 upon lambda is known as the wave number. So these were some different forms of the same formula, where this is the wave number. Now after this theory, one more theory came out, that was Bohr's atomic theory. Now we will study about this theory in detail in the next lecture, but I'll tell you some formulas that you need to know to understand this theory. The first formula is of Coulombic force. Coulombic force or electrostatic force. So I've already told you that when two charges Q1 and Q2 are kept at a distance r from each other, they will experience a force due to the other particle. This force is given by k times Q1 Q2 upon r square, where Q1 is the charge on one particle, Q2 is the charge on the other particle, and r is the distance between them. Here k is a constant. Now second formula is centrifugal force or centripetal force. I'm sorry, it is centripetal force and not centrifugal force. These are the same forces. Centrifugal. So whenever a particle not charged, it is undergoing circular motion about a point, it will experience a outward force. This outward force is known as centrifugal force, and if we change the direction of this force and we take it inwards, it is known as centripetal force. In this case, we will be studying about centrifugal force. So this particle, because of its speed, that is v, or velocity, that is v, and its mass, it will experience some force outwards, and this force is given by mv square by r, where r is the radius of this circular orbit, v is the speed of this particle, and m is the mass of this particle. This force is known as centrifugal force. The third important formula that you need to know is angular momentum. Angular momentum. So as you all know that momentum is mass times acceleration, mass times velocity. This is a vector quantity, that is mass times velocity. We will not be dealing with vectors in chemistry, so I'll take it just mv. And angular momentum is defined as r times mv, that is mvr. This is angular momentum. So these were the main three formulas that you needed to know to understand the Bohr's theory.